Hello! Today we're going to talk about the life zones of Colorado. So, in all my biology classes, the topic of life zones comes up when we get to talking about ecology and the different biomes that exist on the planet. So, here we are looking at an aerial view. I took this from an airplane while flying over the Rocky Mountains on my way somewhere west of here. This is where we live. There is a dramatic topography in Colorado. It's one of the coolest things about living here. We have a 10,000-foot elevation change from border to border, and as you can see at the very top of our mountains, we have an alpine life zone, which many states in the United States don't have because they have no mountains over 11,000 feet. All right, so here in Colorado, we have a total of 6 life zones. 5 of them are elevation specific, and the sixth, the riparian life zone, weaves its way through all the other 5 life zones. So at our lowest flanks on the eastern border of Colorado, we have prairie. Prairie is dominated by herbaceous species, meaning there are no woody species, there are no trees. It's all grasses and flowers. Then as we go up, we start to have woody species in the form of short trees and shrubs in the foothills, but we still see an assemblage of grass and flower species as well. In the Montane, as we continue to rise through the mountains, we have the largest woody species in the entire state, ponderosa pine. The Montane is where there's like a dramatic change in the slope, and so water aggregates here, and so we have the most biomass here in the Montane. And then as we keep going up, we get to the deep dark forest, where there are many trees, but they are not as large as the ponderosa pine. They are tightly packed in these high slope regions. And then finally, the alpine above 11,500 feet on most slopes, we find a treeless landscape, one that lacks woody vegetation once again. And this is due to a lack of moisture, just like in the prairie. So what we see is that in the extreme life zones, we have less water, and then in the middle life zones, we have a bit more. So let's look at the details of that. So as I just described, the plains, foothills, montane, subalpine, and alpine life zones are elevation dependent. Um, Depending on aspect, which is which direction the slope is facing, uh, these are ranges. They are not very specific. So, for example, on northern slopes, the ranges tend to be a little lower in elevation because there's more moisture. Um, it's the sun does not shine on the northern slopes in Colorado in the winter, so there's more moisture capacity. Um, and then on the western and southern slopes, it's drier and a bit more um, there's a bit more solar radiation because in the winter, the sun is hitting these slopes. Then we have the riparian life zone that really weaves its ways from the headwaters of all of our streams in Colorado all the way down and out to the oceans, not depicted here in this graphic. So, as I've emphasized, elevation is the key factor in Colorado, especially where we have dramatic changes in elevation. But there are other factors like climate, which are related to, for example, the aspect and the slope, or excuse me, the aspect and latitude of the landscapes. And here in Colorado, we are right around 40 degrees in latitude. And then, of course, there are different soils. So, depending on where you are on the landscape, there could be more or less soil aggregation. You could physically be closer to the bedrock. And we see that down here in Colorado Springs within all one life zone, right, there's great variability. So like if you're in the Garden of the Gods, you can see the basement rocks protruding from the soils. There's no soil on the red rocks. But then where the soil aggregates just below, there are many soils of many different kinds. And then those abiotic factors that I just described give rise to the biotic factors in the life zone, the animals, the plants, how the animals and plants interact. And then finally, of course, there's the anthropogenic effect of human-induced threats to ecosystems. So, in the prairies and grasslands, as I mentioned, there are no tree species. And in fact, the riparian life zone in the prairies and grasslands contain only one woody species, the cottonwood, the one woody tree species, the plains cottonwood, and then there are some woody riparian willows, etc., on the salix family. So what's it like on the prairie? There is less rainfall than in the mountains, but more than in the desert. So think about how the prairie, hopefully if the range is in good health, it has 100% cover with plants and grasses. But if you're in the desert, you might have large areas of bare ground. So that's kind of the difference between the prairie and the desert, and that's related to rainfall. And then we have temperature. So in the prairies, it's cold in the winter and it's hot in the summer, and these are dramatic temperature changes. And here in Colorado, we have a windswept landscape where it can be cold in the evening and hot in the day. So in a single 24-hour period of time, there could be 50 to 60 degrees of temperature change, degrees Fahrenheit, in a given 24-hour period of time. And then we have geography, of course. So this PowerPoint, I've had it for a long time, maybe close to 20 years, and the original creator of the PowerPoint was the Denver public school system. So we're talking mostly about the eastern slope in these images and generalizations, but essentially in Colorado, whether you're on the eastern slope or the western slope, gives rise to like the predominant weather patterns. So on the eastern slope, we get moisture coming in from the Gulf of Mexico, on the western slope coming in from the Pacific. And so here on the eastern side of the mountains, we are in the rain shadow because although we do have Gulf of Mexico storms, the predominant storms are westerlies coming from the Pacific Ocean. And so most of the moisture falls on the western slope of Colorado mountains of the Continental Divide in the Rocky Mountains in Colorado. In the prairie, there is very great soil development compared to anywhere else in Colorado. And this you can really think about as a factor of slope. So the prairies tend to be low slope environments, and so water is not moving the soils across the landscape very dramatically. They're sort of gravity's winning. The soil is staying in place unless we have, a windswept landscape without any vegetation. Then the wind velocity might cause the soils to be depleted, but we don't have a steep environment where the soils are sliding off of the landscape and collecting somewhere else. Where are they collecting? Right here in the plains. So, as we've discussed, the canopy height in the plains is really low. Notice we have the exact same graphic here in the Alpine, and then in between we have those woody species that I started with. So what kind of plants grow on the prairie? Our predominant plants in the Colorado prairie are grasses, and we have a co-dominant grass community of buffalo grass and blue grama. And the blue grama, you might have heard of, is called eyelash grass because it looks a lot like eyelashes. And in fact, the buffalo grass also looks like that, but the seeds are the inflorescences are very small, so it's hard to see. We also have taller grasses like needle and thread. And so when we think about the adaptations that help these plants grow in the hot and dry climate of the prairie, one thing to think about is the shape of the leaf. the leaf is very narrow, and the orientation of that leaf is straight up and down. And so this is one adaptation for living in a very high solar radiation environment. Every time the plant opens its stoma to collect gas for photosynthesis, water escapes. And so it would be best if plants were doing this photosynthesis in the morning or evening, when the sun is at a lower angle and it's less hot, for less moisture loss. And so when you think about, for example, the leaf shape of a grass, that's an example of an adaptation to the ecosystem, to the environment in which grasses predominantly live, in the prairies. We also have succulents and plants like yucca that live on the prairie, and these are plants that have special photosynthetic pathways and or special leaves to hold the water inside. In Colorado, southern Colorado, we do have cacti, and then as we progress in higher latitudes, we kind of get away from that, but we're at a neat transition there in latitude. So, looking in the background of this picture, you can see the prairie just pancake flat out there. And you can think of that as, you know, the soil deposition zone, and all the water is moving off of the mountains. So when we enter the foothills life zone, we have variable slopes, and we're starting to see the geological features of our landscape, a lot of very interesting geological features. So for example, in the foothills near Denver Front Range, we have Dinosaur Ridge. We have more fossils discovered, dinosaur fossils discovered in the foothills life zone of Colorado than almost anywhere else in the world, because that bedrock is really coming right up. The fault is running right along the Rocky Mountains, and we can see that geology. The foothills in Colorado is between 55 and 8,000 feet. So that's basically anywhere east of the Front Range, all the way up to our mountain communities just above the city, like Genesee outside of Denver. In the interior valleys, like Buena Vista is 8,000 feet. And so we see just a slight rise in elevation from the prairies and grasslands. And remember, Denver is called the Mile High City because it is 5,280 feet above sea level. So when we think about prairies, you know, we're butting right up on the foothills in the highly populous region of the Front Range of Colorado. And so we're right at that transition between the prairies and the foothills. In the foothills, the weather is always changing. So remember, I was describing how like the Gulf of Mexico storms like hit the Rocky Mountains. They literally travel across the landscape until they hit the Rocky Mountains. And then the rain falls because as the air is pushed up against the mountains, it becomes colder and its ability to hold water decreases. And so we have rainfall. Then on the western slope, that's happening even more dramatically with our more dramatic weather patterns coming in from the Pacific Ocean. And then regarding temperatures, it can be super hot in the summer, hot like a desert, and in the winter, it can be cold. So we see again that same characteristic high range of temperature changes in the landscapes of Colorado. The geography. So as I mentioned, we're just right here in the foothills. We're butting up against the mountains and we're meeting up with the prairies. So there's a lot of variability right here. There's some places where there are rolling hills. There are some places where there are jagged rocks, deep riparian corridors. And we find that the soils here are sandy and they have a lot of rock in them because if you think about it, this is the deposition zone, this in the Montane, of all the debris that's coming from the highest peaks. So in the foothills, we have medium stature trees, and we have the oak and pinyon forest. So interesting fact, the pinyon pine and juniper and oak forest is the most abundant ecosystem on planet Earth. There are more landscapes on planet Earth at our latitude that have this same medium stature forest on it. I think that's really interesting. Like, so for example, here in Colorado Springs, one of my students once told me that like they do combat training right below Cheyenne Mountain at Fort Carson for Afghanistan because this landscape is very similar to the landscape in Afghanistan. Um, so here, as I mentioned, we also might see some cacti. We still have our grasses and we are starting to have woody shrubs, for example, the sagebrush. And then as we transition from the foothills to the montane, we have these massive trees called the ponderosa pine. These are the largest trees in Colorado, and they have some great fire adaptation. So if you go up to a ponderosa, you'll see that the bark is extremely thick and furrowed. And this is a fire adaptation. So fires could come in and have high frequency, low intensity fires. So in this lower corner, imagine like the grass and some of the small saplings are burning, but these big stately trees, they're surviving the forest. And so that is a fire adaptation. We were talking about how like a grass leaf is narrow and upright, and that's an adaptation for living in a droughty environment. So here we get to the montane. And again, just keep thinking about how the landscape slope changes. So in the foreground of this picture, we have a beautiful riparian life zone, and that's where there's soil aggregation. Look at all that lush biomass. And then as we climb these flanks here, right, we're getting into the forested landscape for the first time. The montane in Colorado is between 8,000 and 10,000 feet. So thinking about how far up that is, like most roads in Colorado do not exceed 10,000 feet. And so basically this could be anywhere from Leadville to Georgetown, like Estes Park in Colorado Springs area, Woodland Park, all the way up over the passes. So like there's a road in Leadville, Colorado, the highest incorporated town in North America, 10,000 feet high. Above 10,000 feet, I would argue that, there's a few mountain passes, but there might be some dirt roads in the Forest Service lands. But basically, the montane is the end of permanent civilization, right between the montane and subalpine. So in the montane, there is a lot of snowfall, there are a lot of thunderstorms. I mentioned before that this is a very mesic environment. Not only is the water moving downhill and aggregating in this lower slope environment, the storms are slapping up against the mountains and the water's falling here. The temperature, it's a bit more stable because it's a forest, right? And so, and the forest creates a buffer in numerous ways. It reduces the wind, and the wind causes desiccation on the landscape. Also, the wind like pushes the geothermal heat away. But in the montane, there's a bit more stable temperature. As we've been discussing, we're between the foothills and the subalpine, so we're moving from a like small statured tree environment to a large statured tree environment. And there's great variability with aspect. There's a lot of large animals in the montane. The soils, again, related to slope, they are beginning to aggregate here in these big wetland complexes. The montane landscape in Colorado has the tallest trees we have the ponderosa pine and the montane, and then we have our subalpine species intermixing. So one of the characteristic species in the montane is the Doug fir, and there's this fun little adage, flat, friendly fir. So when you reach out for a fir, the needles only have two sides, and it's smooth, it doesn't poke you. So that's how you can know you're looking at a fir. And then the Doug fir, it's has these interesting cones, which have these papery bracts, which are sort of looking like the back ends of squirrels. And so this is really characteristic. There's no other cone in Colorado where you can see this bract like extending beyond the basic shape of the cone. Okay, and Doug fir are great for construction, and think about how this would be an important species for early settlers in Colorado who were clearing the land for mostly mine prospecting originally, and building various structures with this wood. Also, lodgepole pines. So getting back to the heritage of Colorado and the mining history, lodgepole pine are only dominant in places where the forest was cleared. So like for example, in lower elevations in Summit County, like there's just the pine beetle problem is just extensive. But imagine that Summit County was like completely clear cut. It was one of the largest mountain settlements. And so the secondary growth is the lodgepole pine. But then when you get a little bit higher up into like Blue River, it's predominantly spruce. And so in places where there was not clear cutting for mining, you see this spruce fir pine balance. But where there was a clear cutting in the time of mine prospecting, it's predominantly lodgepole pine, and pine beetle are native species, but due to climate change and due to this anthropogenic change in the forest composition, the pine beetle are overtaking the trees. But they are not invasive, non-native species. They are native species. It's just their life cycle is out of whack. Also, in this life zone, we have a lot of aspen trees, and what we'll find when I lived in Summit County, ecologists like me, they put some positive optimism spin on the pine beetle, and that is that with forest clearing, the aspen groves extend, they become more abundant. Aspen are thought to be the largest ecosystems on the planet. They are Each aspen tree is connected to its neighbors through rhizomes. These are underground roots. And so um, a single grove, say that all turns this reddish orange color. That's all one organism. It's so amazing. But since it's one of the only deciduous species in Colorado, other than in the riparian, there's pretty good soil development. This deciduous biomass that falls off the trees every day, called leaves, enriches the soil. So there's a lot of wonderful wildflowers and diversity under the aspens, but their nearby deep dark forest neighbors like the spruce fir and pine do not let enough light go to the bottom of the forest floor for there to be great herbaceous plant development. Furthermore, needles live for 6 to 8 years, so there's not that constant recycling of nutrients the deciduous biomass provides. Okay, so we have the Colorado Columbine and the Indian paintbrush. These plants are all over in every single life zone, but they do particularly like to live under those beautiful aspens, so they look most stately in this landscape. Oh, finally, we get to this deep dark forest. I like to call it the deep dark forest because I used to live in Summit County and I thought it was kind of boring because I like plants. And under these vast forests of spruce, pine, and fir, There's very little plant development, as I just mentioned. There's a heavy cover of needles, and needles contain lignin, which is a recalcitrant material that doesn't break down very quickly. Also, acidifies the soil, although that's not a huge problem in Colorado because we have limestone bedrock, so that is basic. So it's not so much the acidification, but it's the lack of solar radiation that prevents beautiful wildflowers from occurring under the deep dark forest. Although you will find kinnikinnick and heartleaf arnica and other species like this. So as you can see, we're getting up there. We're getting high up in the mountains, 10,000 to 11,500 feet. The deep dark forest of the subalpine. The winter is long and the summer is short. So in Summit County, like we barely had a summer. It was like 4 weeks because there were just these long mud seasons on either end of the winter, and the winter was like 6 months long. So without that solar radiation, the snow holds. This is where the snow is holding on the mountainside. It's being stored basically until there's a warmer season in the spring. And it typically stays freezing, right? So the Montane is low enough that there could be some freeze-thaw cycles throughout the winter, but in the subalpine, once it's cold, it pretty much stays cold throughout the winter. And there's variation based on aspect, of course. So like aspen groves and meadows are typically on western and southern slopes, and where the sun shines in the winter, but the deep dark forests are on the northern and eastern slopes where the sun literally does not rise over the peak of the mountain, so it stays shady. And here we could have deep soils in flat meadows, but where the slope is steep, as depicted in this picture, there's not a lot of soil development because any moisture that's moving across the land is increasing the velocity of the soil itself. It's pulling the soil along with it. So I keep mentioning the species in Colorado, but we have lodgepole, limber pine, Engelmann spruce, subalpine fir. We have the Doug fir, which is actually a false fir. It's called Pseudotsuga menziesii. And then we have bristlecone pine and some other species not depicted right here. But what are the adaptations do these trees have in common? Well, it's a harsh environment, and so having a needle, for example, is an excellent adaptation. The caloric investment a tree puts into making a needle lasts. The needles last for 6 to 8 years, but when an aspen tree puts forth a leaf, that's a lot of effort for a leaf that's only going to stick around for less than 365 days, closer somewhere to 9 months or so, and then the leaf will fall off and it will be winter and new leaves will grow. So there's a big caloric investment in making leaves. Having needles is an excellent adaptation for living in a cold, dark environment. Also, the way we see, especially in the spruce trees, the reproductive parts, the cones, are all at the tops of the trees. We see here also subalpine fir cones at the tops. In these trees, the cones are out on these extended branches. And this is to facilitate pollination by wind. So that's another adaptation. If you live in a windy environment and you're not offering showy flowers, you need a way to get your reproductive work done. And so conifers are in their own whole subsection of plants, right? So we have flowering plants called angiosperms, and then we have cone-bearing plants called conifers. And those are completely different strategies for exploiting the environment in different ways. Finally, we get to the alpine life zone. In the alpine, there are no longer trees. And this might seem a bit weird, but I'm going to tell you that the alpine environment is the driest environment in Colorado. Although all of the water that falls on the continental divide goes forth to provide moisture to the landscapes from here to the Gulf of Mexico and from here to the Pacific Ocean. The place where the snow actually falls on our Rocky Mountains, on our continental divide, is in fact a very dry environment because it's so windy. So there is this phase change that we hardly talk about in science, but it's called sublimation, where water goes straight from being a solid to a gas. It has no liquid state. And that is what's happening in our alpine environment in the winter. And so the moisture is locked up in snow, and then when it gets warmer, it moves with high velocity downhill. But the plants that are actually right here in the alpine, they don't have a lot of moisture to work with because there's not a lot of liquid moisture right here. So this is why the plants are so tiny in the alpine. And I have other videos where I show how like a plant in the alpine, like a columbine, could be as small as one knuckle of my finger, and then down in my garden it could be 3 feet tall. But they're all in the same genus. It's still a columbine. And so we can talk about that on a different day. But realize that in addition to this lack of moisture, the the alpine plants, they need to have a very fast reproductive cycle. They have to carry out their life cycle as quickly as possible because temperature is a concern. It's around freezing every night of the year. And so if you're going to set a flower and set a seed and hope for the best to make babies for the next year, best that you're not busy making a lot of vegetation for a long time because you'll never get around to making the flowers. So in the Alpine, as I mentioned, we have a lot of the same exact plants that we have down in the prairies and the life zones in the foothills, in the Montane, etc. But the plants are extremely small in stature. We do have a lot of species that grow with like a mat forming vegetation. So they're all like very low to the ground and the roots are connected, kind of like how I described the aspen roots to be connected. Also grasses do this. It's called vegetative growth. In fact, this is just a great strategy for life in Colorado because everywhere in Colorado, the moisture availability is low compared to other locales. Everywhere in Colorado, the temperature variations are dramatic compared to other places in the world. So in the Alpine, we have a lot of small mammals. We have a lot of animals in the rodent family. So we have pikas, we have marmots, and these are animals that are working very hard. The pika is thought to be the most efficient organism on the planet. So in this top right, we see the pika doing this activity called clipping. The pika are collecting, they're foraging, they store all of this food in these little hay piles in the rocks. It's the cutest thing. And then they proceed to eat that in the winter. I've even heard that pikas eat their own poop if necessary, because that's an efficient thing to do. We also have animals exhibiting an interesting color change adaptation. And this is one thing that's getting a little bit out of whack with climate change. So ptarmigan, snowshoe hare, there are a bunch of species that exhibit a coat change. So when their environment is predominantly snow covered, their plumage is white. And when it is not snow covered, when there's just rocks and vegetation, the plumage is more brown and muted to be camouflaged to that environment. But I have recently read a paper about how these cycles are becoming disconnected. So like species still have their white plumage, but the snow has already melted, making them easier to spot. And then in every textbook, you'll hear about the moths in the Industrial Revolution that were white or black, and although the black was very rare, it became increasingly abundant because the trees were covered in soot, whereas they had prior been covered in white bark. In the food web in the Alpine, we see that our top predators are largely birds. But other than that, we have the same kind of food web that we would see in any life zone. We have insects and vegetation that are some insects eat vegetation. Some insects eat other insects. And then we have the vegetation providing the primary production for all species. Only photosynthetic organisms can harness the energy of the sun and convert it into sugars for consumption. Um, and then finally, we are in our riparian life zone. I formerly was a riparian researcher, and I'm getting back into it, and I'm really excited. Rivers are the lifeblood of all ecosystems, and it's just so interesting in Colorado to see their entire lengths, right? We have the great fortune of having headwaters right here in our state. So you could go to the place where the river starts and you can follow it out to the plains where the river is huge aggregation of water from all over the place. So the riparian life zone extends throughout. There's not really rivers in the Alpine, but these are the Alpine meadows are the start of all rivers down below. So the climate is going to be the same as the surrounding landscape, but the temperature is going to be cooler because all of that vegetation creates a microclimate. So as the plants are transpiring, the water, as I was saying, the leaves open their stoma to take in gases and release water. So imagine if you are in an environment where there's a ton of woody biomass, there's a lot more of this water release coming out of the leaves, and that's creating a more humid environment right near the river. And then depending on the landscape and the geography, the waters may be moving quickly or slowly, and that would have huge impacts on the dimensions of the riparian areas. Now, since moving water tends to pick up soil and take it with it, most riparian areas are pretty gravelly. But what we're seeing is that, a lot of anthropogenic change increases the sediment loading in these creeks, and increased sediment from road development, for example, is bad for fish spawning. It creates a completely different environment for the organisms that live there. So in on the edges of riparian areas, which are lakes or rivers, we have certain species that are very unique to these landscapes, like the sedges and the cattails. We also have all these woody riparian species like alder and willow and cottonwood. And so as I mentioned that there could be deciduous plant matter in the riparian area, even if you're in a life zone that doesn't have trees, like the prairie. Or the alpine, where you have like alpine willows. They're not high in stature, but they have a deciduous leaf, and they are woody. So in summary, we talked about all these life zones. This is a very long video. I'm sorry I tried to talk as fast as I could, but I hope you gained a lot of knowledge, and I hope this was helpful. I want to leave you with this one cool picture. I would just pause the video right here so you could take it all in and accept what it means. But if you believe me, this image describes absolutely everything I just said in the last 38 minutes. So take a look and see if you can figure it out. And I'll tell you that these different sides of each line are related to aspect.